Hi, and welcome back. I just went and bought another radio, another vintage radio. This one is a Tram Diamond 60 23 channel radio with sideband. And what's cool about this one is it has extra channels. It has a switch on the bottom that has 4 different positions. So with 4 different selections and 23 channels, 23 times 4, that gives us a possibility of 92 different frequencies. And sweet thing about this radio is it does work. Let's see, let's tune it in a little better.
CQDX 2000 Central Indiana, standing by. Hey, I have here.
2000 Indiana, 595 Northern Nevada.
595 Northern Nevada. We got a copy on you in Central Indiana. Y'all have a fine one out there in Nevada. 2000 Central Indiana, set it.
2000 Indiana, 73s to you. Have a good weekend. 595. All right, so as you can see, it works. And that was channel 11 on my CB. And like I said, I have 4 different positions on a knob on the bottom. So I call it A, B, C, and D. Position A is channel 1 through 23. And position B gives me all the way a little past channel 40 or into the free band frequencies. So on this channel 11 is actually channel 37. So I'm getting ahead of myself here. I'm going to show you in a moment how I figured out what all the frequencies were. And, you know, I was kind of stuck. I go, boy, how do I figure out all these frequencies? And then it just popped into my head a really easy solution to this. So I'll talk about that in a minute. When I got this radio, it didn't really work. The switch on the bottom, it was really sensitive and it wouldn't get all the frequencies. These weren't working very well, all the control knobs here. So I opened this up and let me grab it over here. I have a can of electronic cleaner. I just sprayed all the contacts, turned the knobs around, and that pretty much fixed that. And I was going to replace the capacitors in this. And I ordered them all. And as you can see down here, I have all the capacitors for it. And the trouble with this is the circuit board on this is really old. This radio weighs a ton. And most circuit boards on the radio, you can see through them. This circuit board's really thick. And I don't think they use, maybe it's lead solder or something. I don't know, but it was a pain to get the solder off the contacts for the capacitors. So I was able to get one off, and that was this big capacitor here. And the reason I wanted to replace the capacitors is one report said I didn't sound very good. But after going inside that radio, I decided it's not worth the time and effort. And if it was lead solder, I really didn't want to breathe the fumes from it. But I don't know if it was just the report I had or just replacing that one capacitor. But I get really good reports on this radio. So I decided I'm going to leave it as B and add it to my radio collection here. All right, so like I said, I have 92 different possibilities for channels. When I'm on selection A, I get 1 through 23. When I'm on selection B, we start getting above channel 23. Actually, channel 1 on selection B is channel 23, so that's repeated on the A and B position on the switch. But anyway, I decided I have a software-defined radio, and I decided to use that to figure out my frequencies. And so let's plug it in, turn it on, and we're going to go directly to position B on the switch on the radio and look at what channels we get in position B. All right, so as you can see here, I have software-defined radio. And we turn it on over here, and as you can see on my chart here, I pulled up the CB band, and I have the 10 meter band here. So, we said we're on channel 2 on the Tram radio over here, and that should correspond with channel 26. So, if we key the mic, you can see channel 26 spiking there. All right, so on the Tram, we are on channel 2, which should correspond with channel 26 on the CB, which is 27 point, oh, it should be 265. Let's line it up. When we key the mic, that red line should align with the peak of keying the mic, which it does. So I think you can see where I'm going here. Let's look at a channel above the channel 40, and I'll show you how I figured it out. Okay, I have the CB now on channel 14, which is above channel 40. So let's go ahead and key it. And you can see where it's spiking over there. And let's put channel 40 in the frequency here. So 40 would be 27.405 megahertz. And as you can see, the spike there is above channel 40. Now, I know that with the crystals in here, they're spaced apart. I think it's kilohertz. Yeah, they're spaced apart, I think, 10 kilohertz. So let's go ahead and increase that by 1. And this should correspond to channel 41. Which it does. So there is no channel 41, but that would be, with the crystals in here, the next step up from channel 40. So that's what I did all the way up into the 10 meter band to figure out the frequencies. Now, before I show you all the frequencies I mapped out and I placed in a spreadsheet, let's look at the CB band or 11 meter band. It starts at 26.965 megahertz and goes all the way up to 27.405 megahertz. Now, if you look at the chart here of the ham radio bands and you go down to the bottom center, the 10 meter band is from 28 megahertz to 29.7 megahertz. And if you notice, from 28 megahertz to 28.3 megahertz is for RTTY data only. So those aren't frequencies that you talk on the 10 meter band. So when I show you what I mapped out, you'll see that I don't get above I don't get past 28.3, so that's not a frequency I can talk on the 10 meter band. All right, so here we are now. Here are the frequencies that I mapped out on the radio. So you can see 1 through 23 on the A frequency, or the A selection switch, gets me channel 1 through 23, just how the radio was from the factory. When I select B, 1 through 13 will get me 23 to 40. Now you notice some of the channels aren't in there, like 24, 25, 28. Let's see. And 38 aren't on there. So once you get past 13, you're getting into what's called the free band range, and that's in the yellow. The yellow's still in the 11 meter frequency range, but it's above what's legal. So you're not supposed to be on these frequencies. And flipping around and listening on what I called channel 41, 42, 44, 45, I heard quite a bit of talking on that. Now, some of these frequencies are used by businesses, and I think one of them might even be some type of aviation, or I'm not sure. But these are frequencies that you probably don't want to be on. But I just think it's kind of cool that this radio does that. Then when we go on setting C, you can see, you can see we're still in the 11 meter band. Then when we go into the setting D on the switch, we're still in the 11 meter band. Then when we get to channel 15 through 23, we are now on the 10 meter band. So there you have it. By using that SDR software, I was able to map all the frequencies on the radio. So there you have it. There's the Tram Diamond 60 with sideband. Pretty cool little radio. Still works really well. I'm actually really surprised that the capacitors still work well enough that this radio gets really good reports. And like I said before, I don't really plan on talking above channel 40 on the 11 meter band. I'm not comfortable with doing that. I'm not really sure what those frequencies are used for. I know some of them are used. And the 10 meter channels it does get are limited to, even though I have my ham license, those frequencies I do get are not on the frequencies that you talk on. So thanks for watching. I just wanted to share this cool radio with you, and I will see you next time.